Hello class. Hi there, how are you?
Hey, Louis, how are you?
Good, good. So
last time we just did the RL circuit, and now we're going to do the RLC circuit by adding a capacitor to the circuit.
yes, it's very important for all of electronics. Now we have an AC source, just like we had last time. This is a function generator. Frequency is this is right now 2.1 kilohertz and 2 volt, but we can change that. Then we have an inductor, a capacitor, never mind this little curvy symbol, this is just a capacitor, and a resistor, and this is ground. And everything is in series. Now the thing about this kind of circuit is that because the source has an alternating voltage, the voltage at each of the elements will change with time. And they're not all going to be in sync because they have different response to the current. So the way we analyze this kind of circuits is to use phasors. So these are vectors in this abstract space, and they turn counterclockwise, and the instantaneous value of the voltage at any one of the elements is just the horizontal component of that vector. So then the idea is that the current, let's say the current is here at some moment of time, that's the phasor for the current. Then using Ohm's law, the voltage of the resistor is the same as the voltage of the current, so they're in sync. They're in the same time, and versus the inductor is the derivative of the current, so that will lead the current. VL will be di dt. And the capacitor, on the other hand, will lag the current because it's the integral. So it goes this way. So that's how I have my three vectors. And
now if we look at the oscilloscope, we have two colored traces here. So the yellow trace indicates the voltage output of the function generator, which we will denote as E naught. And the blue trace indicates the voltage across the resistor here.
exactly, good. So let me put them back on top so we have two traces. So number one, let's put it back down. And number two, and right now, they're right on top of each other. Great. So let's say I lower the frequency. What do you think is going to happen?
If you lower the frequency to 0, that's essentially just a DC circuit.
Right.
In DC circuit, at steady state, the inductor will just become a wire, so there's no voltage across it, and the capacitor will just store up the charge, so you will have voltage across it.
Good, so let's see that. So that means that, maybe let's draw this. So you're saying at lower frequency we have almost nothing in the inductor. So this decreases. That means this one is bigger, and the resulting EMF for the whole thing will be the vector sum of these things, and so it should be, since this one is lower, in fact it could go all the way to 0, it should be around here somewhere. So this is EMF naught, this is the voltage of the source. And the more important thing is it should lag behind the current, and it should lag behind VR. So let's see that. Okay. So what we're seeing is here VR is the blue source. VR reaches its maximum value before the yellow source. So it works, it lags. And looks, VR is also smaller. Why is that?
The VR is smaller because at low frequency there will be a large voltage across the capacitor, which is going to eat up the total voltage across the resistor here.
You don't get much. So you lower the response of the resistor as you decrease the frequency. Okay, makes sense.
So now what if you crank up the frequency?
Okay, let's move it back up. So I'm now at 0.7 and moving it up.
Oh, well, stop there.
Oh, okay.
I think that's the resonance frequency.
Oh yes, that's important. Okay, good. So the resonance frequency, they're right on top of each other. So that must mean VL and VC are exactly equal. So that's the time where the voltage is equal between these two, and then they essentially cancel, and then the voltage of the resistor is equal to the EMF. Great. Then if I go up, what happens? So VR again decreases, but this time the yellow trace reaches its maximum before the blue trace. So where we are now is we're in the other cases. We have VL, VC small, and then we have so the yellow trace now, because VL doesn't like, so the inductor doesn't like it when the current is changing a lot, so high frequency, it eats up a lot, takes most of the voltage, and so then will lead, the yellow trace gets ahead before the blue trace. Okay, great. Super important circuits. Resonance, you get the maximum response, and then on either side of the resonance, either the current will lag or lead the EMF. Great.
physics works.
Yeah, it does. Yay.